Hai, saya Teacher Shazra. Okay, here is topic number 5 in STPM syllabus for chemistry, that is reaction kinetics. Okay, our subtopic is rate of reaction. Okay, here is activation energy. Okay, so activation energy is the minimum energy needed by the reactant particles to react. Okay, the symbol for activation energy is EA. Okay, here we have an energy profile diagram. Okay, so here is the reactant. Okay, and here is the product. So where we should put the activation energy? Okay, from the definition, activation energy is minimum energy needed by the reactant. So at this energy profile diagram, okay, we should draw the activation energy, okay, from reactant to the peak. Okay, this is we call activation energy. Okay, selain daripada bentuk ni, kita ada lagi satu bentuk di mana, okay, the reactant level is higher than product level. Okay, so for this energy profile diagram, the activation energy we must draw from reactant to the peak. Okay, this is the EA, activation energy. If the colliding reactant particles have energy bigger or equal to EA, therefore it is effective collision. If the colliding reactant particles have energy less than EA, therefore it is ineffective collision. Okay, collision theory. Okay, number 1, molecule of A must be collide with molecules of B before products can be formed. Okay, so A must be collide with B so they can form C. Okay, next, reaction rate is proportional to the number of molecular collisions per second. Means number of molecular collision increase, therefore reaction rate also increase. Okay, next, collision between the reactant particles that produces a chemical reaction is called an effective collision. Okay, pelanggaran yang menghasilkan produk, okay, kita panggil effective collision. Kalau tak ada produk, itu adalah ineffective collision. Okay, next, when molecules collide in an effective collision, they form an activated complex or an intermediate species, which then decomposes to form the products. Okay, so example here we have A react with B, produce C. Okay, C will react again with D, produce E. So here C become the intermediate. Okay, so see here, we produce C, then we use the C. Okay, so C adalah intermediate. Okay, particles that collide must fulfill two conditions. Okay, mesti memenuhi dua syarat. Okay, syarat yang pertama, okay, the first condition, particles must collide with the correct orientation. Okay, correct orientation, okay, A collide with B, produce C. Okay, another example, okay, that's one, dia punya direction tak betul. Okay, so bila direction tak betul, jadi dia tak collide, so tak ada product. Okay, second condition, Okay, colliding particles must have enough energy. Okay, mesti ada tenaga yang cukup lah. Okay, ni contoh tenaga tak sampai. Okay, jadi dia tidak berlaku pelanggaran. So, bila tak ada collision, there is no product. Factors affecting the rate of reaction. Okay, for this syllabus, okay, the factor that affecting the rate of reaction, okay, first, concentration. Okay, the higher the concentration of a solution, the more particles per unit. Okay, semakin tinggi kepekatan, semakin banyak particles dalam concentration tu, dalam solution tu. Okay. So, apa yang berlaku? Collision frequency between particles increases. Effective collision frequency between the particles that have activation energy increases. Therefore, the rate of reaction increases too. Okay, jadi untuk faktor yang pertama ialah concentration. Okay, semakin tinggi concentration, semakin banyak particles per unit volume. Jadi bila particles banyak, dia akan berlaku kekerapan pelanggaran antara partikel itu akan bertambah, akan meningkat. So bila meningkat, okay, effective collision frequency between the particles that have activation energy increases. Okay, jadi bila kekerapan pelanggaran itu meningkat, okay, kekerapan pelanggaran yang berkesan juga meningkat, akhirnya, okay, the rate of reaction also increases. Okay, kadar tindak balas juga akan meningkat. Okay, faktor yang kedua, kita tengok, kita ada faktor temperature, suhu. So, the higher the temperature, the higher the content of particles energy, ataupun the higher the temperature, the higher the kinetic energy. Therefore, collision frequency between particles increases, and also effective collision frequency between the particles that have activation energy increases. Therefore, the rate of reaction increases too. Okay, jadi ini dua faktor yang kita tengok untuk rate of reaction, that affecting the rate of reaction. Okay, reaction rate and temperature. Okay, kita tengok relationship between the reaction rate and temperature. Okay, so the higher the temperature, the larger the fraction of molecules then can provide the activation energy. Okay, jadi bila higher temperature, lebih tinggi suhu itu, lebih banyak molekul yang boleh provide the activation energy. So, bila ada activation energy, tindak balas tu boleh berlaku. Okay, ini kita boleh terangkan, okay, rujuk kepada Maxwell Boltzmann distribution. So, ini dia punya graph. Okay, graph of number of molecules against kinetic energy. So, this graph, first graph is low temperature, and another one we have graph with high temperature. Okay, here is the activation energy. So, this one is area that shaded. Okay, so apa yang dimaksudkan dengan shaded area ni? So, area under each distribution curve is proportional to the total number of molecules. Okay, so area ni semakin besar area tu, semakin besar kawasan tu, semakin tinggi bilangan molecules tu. So, higher temperatures, the fraction of molecules with higher energies increases. Okay, so kita boleh tengok graf yang berwarna merah ni high temperature, and yang berwarna biru ni low temperature. Okay, area. Okay, under the graph, okay, kita tengok the pink color is higher. Okay, lagi luas kawasan yang berwarna pink berbanding berwarna biru ni. Ini menunjukkan, okay, fraction of molecules, okay, with higher energy lebih besar untuk high temperature compared to the low temperature. Okay. Thank you. Thanks for watching. Jangan lupa like, comment, dan subscribe.